Okay, 4 capacitors are connected as shown in figure below. Okay, calculate the equivalent capacitance between point A and B. Okay, so he wants to find the equivalent capacitance. Sometimes the question will ask about effective capacitance. So the word equivalent and effective, same meaning. Yeah, it means total. It means the total capacitance. Okay, so he want to find the C equivalent, yeah, or we can say C total. Okay, between point A and B. Point A and B, so considered to be the C total lah. Okay, considered to be the C total. Point A and point B, so this is the C total, or we can say C equivalent. Okay, so we can label. Okay, first of all, we can label them. This one is C1, C2, C3. This one is C4, right? So as I said, I asked to find the equivalent capacitance. As I said, we always work from branch. From branch, then we go to main circuit. Okay, so we always start off with branch, then we go to main circuit. So our main circuit, of course, is the AB. Okay, this is our main. This is our main circuit. Then this is in the main circuit. 20 microfarad is in the main circuit. And where is our branch? Our branch is this one. This is our branch. Okay, this is our branch. So we always combine C1 and C2 first. We don't directly combine C1, C2 to C4. No, because C4 is in the main circuit. We always work from branch. Okay, work from branch first. All right. So how going to do this? Yeah, I'm going to do this. We can do it step by step. Right? Can do it step by step. I can draw it out for you. I can draw it out for you first. Okay, so now drawn for you. First of all, we start from the branch. Okay, C1 and C2. Okay, we combine this. These two is in series. Okay, these two is in series. Why we say series? Because let's look at C1. One leg of the C1 connect with C2. Okay, connect with C2, and then the other leg does not connect to C2. It does not connect to C2, but it connect to C3. You see that? It connect to C3. Same goes to C2. One leg connect to C1, but the other leg does not connect to C1. It connect to C3. You see that? So it's only one leg connection. So we can say these two, they are in series. Because only connect one leg. Okay, they connect one leg. After that, we combine them in series. We get C12. C12. Look at C12 with C3. C12 with C3. Look at C12. C12. One leg of C12 connect with C3. The other leg of C12 also connect with C3. You see that? It also connect with C3. So both leg connect with the same capacitor. Both leg connect with the same capacitor. So we can say these two they are in parallel. They are in parallel because they connect two legs. They connect two legs. Understand? Between C1, 2, and C3. And then after that, look at so this C1, 2, and C3. Combine, we get C1, 2, 3. See, now we are in the main circuit already. Last time we work in the branch. Last time we work in the branch. Now we have moved to the main circuit. We have moved to the main circuit. I told you we always start from the branch, then we go to the main circuit, right? Isn't it? We don't directly say, oh, C1 and C2 and C4 they are in series. No, this is wrong. C4 is in series with the whole thing here, not in series with only C1 and C2. Understand? We also cannot say that, oh, C1 and C2, they are in series with C3. No. In fact, C1 and C2, after they combine, they are in parallel with C3. They are not in series. Okay? So you must see the connection. Is it one leg or two legs connection? Always start off with doing the branch first, then finally go to the main circuit. Okay? So after C12 and C3 they combine, we get C123. Now C123 is in the main circuit with C4. We can clearly see these two, they are in series. Because why? Because, okay, let's look at C123. One leg of it connect with C4. Okay, and the other leg of C123 don't know connect to who. Same goes to C4, also only connect one leg. The other leg also connect to maybe the power supply, battery, or whatsoever. Yeah, we don't know what it connects. Yeah, most probably it connect to another battery. Okay, so they only connect one leg. So we can say these two they are in series. They are in series because only one leg connection. Okay, so after combine them, we get the C1234. C1234 is the C equivalent. So we can say this whole thing, this whole setup can be represented by one single capacitor, C equivalent, or we call C1234. This one capacitor can represent this whole thing. Understand? If you have this capacitor with this value that you calculated after that, in the end, if you got the C capacitance, this one capacitor can substitute the whole thing here. Understand? Can substitute the whole thing here. Or we can say it can store the same amount of charge. It can store the same amount of charge as the whole thing here. It has the same ability to store charge as the whole thing here. Okay, understand? So one capacitor can substitute the whole thing here. That's what we call equivalent capacitance. Equivalent, can say same level, like that lah. Okay. Okay, so let's calculate part A. Find out what is the value of this C equivalent. Okay, so we start off with doing this one. Okay, let us start. Yeah. So let us start. Okay, it's between. Okay, I need the value. This is 15 and 3 microfarad. Okay, so 15 and 3 microfarad. C1 and C2, they are 15 and 3. Okay, maybe I should write it over here to make my life easier. Yeah, and this one is 3 microfarad, and this one is 6 microfarad, and this is 20 microfarad. Okay, so now let's do it step by step. So this one is in series. We know that in series, okay, we know that capacitor in parallel make the capacitor stronger, isn't it? Capacitor stronger. So if parallel, the C total always plus together, right? Always plus together. So if in series, they must be 1 over C. They must be 1 over C. So this is 1 over C12. Okay, 1 over C12. Remember, in series, look at capacitor in series. Capacitor in series. Always 1 over C lah. The capacitance becomes smaller. Only capacitor in parallel make the capacitor bigger. Plus, you see. So capacitor in series always 1 over C. Okay. So this is 1 over C lah. Okay, 1 over C. So this is 1 over C12 is 1 over C1 plus 1 over C2. Okay, this is in micro. So I write it as 1 over 15 micro plus 1 over 3 micro. Okay, and then what do I have? Let's calculate. Yeah, let's calculate. 1 over 15 micro plus 1 over 3 micro. So I got 2 over 5 micro. 2 over 5 micro. Is this the answer? Is this the answer? No, this is not the answer yet. This is not the answer yet because this is still 1 over C12. You understand? You haven't inverted it. You haven't inverted it. If you want to invert it, you must You must do this. You must do this. Invert it. Okay. So you must invert it. Become, yeah, inverted. Then what it becomes? It becomes, okay. So that's not the answer. That's not the answer. Don't give this as the final answer. It's wrong. You need to invert it because over here is still 1 over c. Okay. So invert it, you get you should get around 5 micro over 2. Okay, you should get yeah, 5 micro over 2. 5 microfarad over 2. That's correct. Okay. So later on, okay, how about over here for this one? Okay, so this is now in parallel. This one is in parallel. So parallel make the capacitor stronger. So it's plus plus plus. Okay, so rub this off. So C1 okay, C1 to 3 after combine is so it plus 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 because it makes it stronger. Capacitor in parallel always plus 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 because parallel capacitor always become stronger. Okay, always become bigger capacitor. Okay, so it's plus plus plus. So is you know, is 5 over 2 microfarad. Okay, 5 over 2 microfarad plus C3. What is C3? C3 is 6 microfarad. 6 microfarad. Okay, what do I get? So 5 over 2 plus 6. So I get 17 over 2 microfarad. So that's my answer. No need to invert because it's what is C. It's not 1 over C here. Okay. Alright, so I got this. So now after combine, I got C123 already. So C123 now is in series with C4. Okay, in series with C4. Let's combine them. But this is one in series. In series make the capacitor become smaller. Series becomes smaller, so it's 1 over C. 1 over C. So this is so after combine, I get the C equivalent already, isn't it? C1234. This is actually C1234. Okay. So this is a C123. This is 1 over C4. Okay. Okay. So 1 over 17 4 over 2 or micro plus 1 over C4. Okay, 17 over 2 micro. Okay, C4. What is C4? What is C4? C4 is 20 microfarad. 20 micro. Okay, so what do I get? So, all right, let's do it. Yeah, let's do it. 1 divided by answer plus 1. Oops, sorry. So again. Okay, 1 over 17 to oops. Okay. Plus 1 over 20. Okay, so what do I get? I get 57 over 340 microfarad. Is this correct? Is this the final answer? Is this the final answer? No, it's not final answer because over here is still C equivalent. So you have to invert it. Invert it. Many students forget about this inversion and how pity is it? Yeah. Many students forget about the inversion. Really pity, yeah. They forget about the inversion. So you need to invert first. So 1 divided by the answer. Finally, you get then only you get the correct answer 5.96. 5.96. That's the answer. 5.96 microfarad. That's the final answer. That's the final equivalent. That's the final equivalent capacitance to represent the whole setup. 5.96 microfarad. Is that correct? Yes, that's correct. That's the equivalent capacitance to represent the whole chunk here, the whole chunk of capacitor here. 1 capacitor to represent the 4 capacitor here. Understand? So that's the answer, 5.96 microfarad. Okay, not this one. Remember when you're doing the 1/c, okay, the inverse function, remember. Okay, 5.96, I got the total capacitance. Now I want to do B. What is the charge on the capacitor? What's the charge on the capacitor if VAB is 15 volt? Okay, so that means what is the charge on what capacitor? Did he mention about which capacitor? Did he mention about capacitor? Is it capacitor 1 or capacitor 2 or capacitor 3 or capacitor 4? Did he mention anything? He said on the capacitor. Which capacitor? Which capacitor? On the capacitor. That means the equivalent capacitor. So it's not all this. Yeah, it's not all this capacitor. It's the equivalent capacitance. Is on the equivalent capacitor. Yeah, that means the whole thing. Yeah. What is the charge of the on the capacitor, on the equivalent capacitor? If VAB is 15 volt, VAB is actually the V total. Yeah, from here we can see AB is actually the main circuit. Yeah, so VAB actually is the V total. Yeah, V total. So how to find? Yeah, how to find this? How to do it? Okay. So this is for the C equivalent. So I want to find the charge. I want to find the charge on the equivalent capacitor. So that means he asked to find the charge, the total charge, isn't it? He asked to find the total charge. So I got the total capacitance already, right? This in fact the C total. This is the C total. Okay. So what I can do is I got the C total already. So how to find the Q total? Very easy. Use the formula Q equal to CV, C equal to Q equal to CV, or C equal to Q over V. Yeah. You know the total charge stored. Okay, because he said VAB. He did say VAB is 15 volt. That means that is the V total. Understand? VAB is actually the V total. Is 15 volt. 15 volt connect to AB. That means wrap off this everything here. That means VAB means he connect this one to a battery. This one, this is the VAB or V total of 15 volt. Okay, and this whole thing here you get. All right, just want to remove all this. Yeah. Okay, so just now I got the C total already, isn't it? I got the C total for everything here. The C total here. I got the C total already. I got the C total. I got the V total. So I want to find what is the Q total. What is the Q total stored in the capacitor? So very simple. So just use the formula. For question B, just use the formula Q equal to CV. Since we are talking about total, so all these are C total, V total, Q total. Okay. So what's the total capacitance just now I got is 5.96 microfarad. You must include the micro. So this 5.96 microfarad, and voltage is 15 volt. 15 volt. So multiply 5.96 multiply 15. So I got 89.4 microcoulomb. Yeah, remember you have microcoulomb because you have microfarad. So you have a microcoulomb. Don't forget your micro. Don't put your answer as 89.4 coulomb. Wrong. Because this one is microfarad, so your answer is microcoulomb. Okay, so that's the answer, 89.4 microcoulomb. Okay, that's correct. Okay, so always for this type of question, yeah, you always find the C total first. Find the C total. After that, then you can, normally this type of question is the first step you find the C total. After you get the C total, you can after that you can get find the C total first. Then after that you can get the either the V total. You want to get the Q total. After that you can get some more. You want to get other things like V1, V2, V3, or V4, or you want to get a Q1, Q2, Q3, Q4. Yeah. If you ask about individual capacitor, and right now this question is easy, just ask for the Q total. He haven't asked about charge in each capacitor. Always you can see the step is you always find the C total first. After you got the C total, then find the Q total or V total. From there you can branch out to get the voltage for each capacitor or charge of each capacitor. Right? This example will be available more in the next video. Okay, see you in the next video. Bye.